Number 7, we have two parts, and first we want to find the slope and the y-intercept, and then we're going to insert those and probably graph it on part 2. So this function is not all the way in slope-intercept form, so we're going to need to simplify. So we have x minus, and then we have fraction bar, we got 3 plus 5x on top. It's all divided by 3. All right, so these two terms on top are not like terms, so we can't simplify. What we will do is write them as separate fractions. So I'll bring down x, bring down the negative. It's going to distribute to both those terms. And then I'm going to have 3 over 3 plus 5x over 3. Okay, this is where you need to do it. That negative is going to distribute and affect everything behind it. So 3 divided by 3 is 1. 1. And then this 5x over 3 will not reduce. 5x divided by 3. And then the last thing I'm going to do from here is distribute. Actually, not the last thing, but the next thing. We have x minus 1, and then minus 5x over 3. And then I need to combine these x terms. So in order to combine them, I need a common denominator. So imagine this being over 1, and they both need to be the same. So I can multiply this top and bottom by 3. And then that will give us 3x over 3. And I'm going to write this one next to it, minus 5x over 3, and then my minus 1. So now we have everything together. We're going to subtract, and this is going to give us a negative 2x over 3, and then minus 1. So now this is in slope-intercept form. We can see our slope is negative 2 over 3, and our y-intercept is negative 1. As an ordered pair, that would be 0, negative 1. Negative 2 over 3. And you have to type this as an ordered pair. Which I have to close parentheses. Whenever you open it, it automatically closes it, so it didn't need that. All right, so there we go. All right, part 2 says we want to graph it. We're going to put ordered pairs. So one of them I'm going to use is the y-intercept. All right, so my slope is negative 2 over 3. This is going to change the y-axis. So remember, rise over run. Sometimes you might see it in some textbooks that delta y means change in y, delta x, change in x. So my y is going to change by negative 2. So I'm just going to do minus 2 from that one. Since this is positive, I'm going to do plus 3 to this one. Just got to remember the order. This is x, this is y, and then it's y over x. So if I do this ordered pair and then I do the math with my rise over run, if I count it from the graph, I would get 3, negative 3 as another ordered pair. So I'm going to use those two ordered pairs. 0, negative 1. And then 3, negative 3. Okay, number 8. We're going to choose the graph for the following function. Okay, so there's this thing that I was taught from another teacher about slope face. So I'm going to show you all the different slopes of linear equations. A couple of different ways to draw them. I'm going to draw them the way he's mad, but you can change the eyebrows. So a slope that is going down from left to right has a negative slope. A slope that is going up from left to right has a positive slope. A line that is going vertically up and down is undefined. That's what this U stands for, kind of like the nose. And a slope that is going horizontal is zero slope. So this tells you all the slopes for linear equations, whether it be negative, positive, undefined, or zero. So this is neat. You get a face. But let's talk about these two special cases. So if you have x equals some number, that will give you a vertical line. The slope is undefined. And then you can notice it from an ordered pair because you would have the same x value. So for example, I could say 2, 3, and then this would be 2, -1. If you see the same x value, that's giving you what your equation is. So in this example, your equation would be x equals 2. This line would only cross the x-axis. That's the only variable that you see, and it would cross at 2. So if I had x and y, this is y, this is x. This would be 1, 2, and that line, let's say 2, 1, 2, 3, and then 2, -1. They would just be on a straight line going up and down like that. So this is with undefined x equals a number equation. And then we have y equals a number. This will be a horizontal line. Its slope is 0. I guess I should say m equals 0. I should put an m up here, m, so you know the slope. What you would notice here is the y value would be the same if you saw ordered pairs, and you have to figure it out. So let's say 1, 4, and maybe 6, 4. Okay, notice the y value is the same. That equation would be y equals 4. And if you saw a graph, it would only cross the y-axis at 4. 1, 2, 3, 4. And then let's say 1, 4, and 6, 4, maybe over here. It'll just be a horizontal line crossing the y-axis at 4. So these are two special cases that pop up. And what we see here, remember function notation, f of x is the same thing as y, and they can use any letter. Sometimes they use p of x, h of x, but anything of this form means y. So this is telling us y equals 1, which is falling into this category. And so we're looking for a horizontal line that crosses the y-axis at 1, which looks like this one here. Option D.